let's do the additional practice for the organic unit. Okay, first up, name some compounds. Let's go ahead and practice. First thing you should do when you're naming a compound is recognize what functional group you're working with. So, first thing I see here is my aldehyde. That's helpful because that's going to tell me where I'm going to start my parent chain. I know I need to start my parent chain to include that aldehyde as that carbon is carbon 1. So 1, 2, 3, 4, 5, 6, 7, or 6, 7. Now, how do I know which way I'm going to name this one? They're going to give me different names if I number it, which way I number the 6 and 7. And here's the trick. If I go 1 through 7 all the way up to the top, meaning these are not done, I have in this one, 1, 2, 3, 4 substituent groups. Okay? If I number it the other way, where I do 6 and 7 over here, I would have 1, 2, 3 substituent groups. You're going to name it so that it has the maximum number of substituent groups. So I'm going to name it so that it has 4 substituent groups, not just 3. That only happens if you have a case where it's going to be different like that. And this one, it is different, so I'm going to name it so that I have my 4 substituent groups. So this group here is called a methyl. This is an ethyl, bromo, and methyl. I have 7 carbons, so I have a hept. And I know it's heptan al because it's an aldehyde. I need to put these in alphabetical order. So I'm going to first put bromo. My bromine is at the 3rd carbon. So 3 bromo. Next up is my ethyl, which is at the 5th carbon. 5 ethyl. I have 2 methyl groups at the 2 and 6. So 2,6 dimethyl. Heptan al. Let's look at this one. Here I recognize immediately that I have a functional group right here of a carboxylic acid. That's also useful because I know that that has to be the first carbon. 1, 2, 3, 4, 5, 6, 7, 8. I could also have done 7, 8. Notice it doesn't matter which way I do the 7, 8 here. It's going to give me an isopropyl group at the 6th carbon. So if I do 7, 8 here, this is my isopropyl group at the 6th carbon. If I do 7, 8 here, same thing. It's going to give me the same compound. So let's do this. I have 8. I know 8 is oct. This is going to be an octanoic acid because it's a carboxylic acid. I have, and sometimes it's easier to see or highlight the chain so you can see what's attached to it. Sometimes that's easier for people. I don't have a preference if you do that or not. I have 1, 2, 3 methyl groups and an isopropyl group that I need to name. So isopropyl comes before methyl, so I've got 6 isopropyl. And then I've got 3, 5, 7 trimethyl, because I have 3 of them. Trimethyl octanoic acid. See, down here I've got a couple things going on. I've got an ester and an aldehyde. Esters take priority over an aldehyde. Remember, esters are named by finding the group that's from the alcohol and naming that first, and then finding the group from the carboxylic acid second. Okay, so I'm going to name these in 2 parts. So 1, 2, 3, 4. Let's see. I've got, my brain is tired and I apologize. 4 is bute. I've got a 2. I've got a double bond at the second carbon, but it's 3-chloro. I've got a 1 and a 2 dimethyl. Because this is not the ending, I'm going to call it EN, E-N instead of E-N-E, because it's not the full parent name. I think I named everything though. I've got 1 and 2 methyl, 3-chloro. Yeah, okay. So to start its name, I've got 3-chloro, 1, 2 dimethyl, but 2 enol. That's the alcohol portion. And then the acid portion is 1, 2, 3, 4, 5 with a methyl group here. 2 methyl, pentan, O8. This one over here, this is an alcohol. It's a secondary alcohol. So I just need to name it to minimize the number on that alcohol group. Let's see, 1, 2, 3, 4, 5, 6, 7. If I counted the other way, 1, 2, 3, 4, 5, 6, 7. That's what I thought. So it won't matter which way I count it. My other branch, my methyl group, will be 3 and 5 no matter what. So it doesn't matter which way I count it. It's a symmetrical compound. I've got 3, 5. So there is a comma right there. That's not showing up really well. 3, 5 dimethyl. Hept and OL for alcohol. This group here, I've got that triple bond I've got to put in the chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is dec. If I highlight it, sometimes it's easier to see the attachment groups. Okay, I've got a methyl group here, methyl group here, an amino group here, and 1, 2, 3, a propyl group here. So I've got 7 amino. Let's see, methyls come next. 6, 8 dimethyl. 4 propyl. Dec, 2 ine. Definitely missed this one because I zoomed in. Okay. It's a ketone. This functional group here is a ketone. So I'm going to number it to minimize that. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I got a deca again. I've got methyl groups at the 3 and 4 carbon. And a phenyl. Because remember that benzene ring attached as a substituent group is called phenyl. So I've got 3, 4. Dimethyl. Let's see, 8 phenyl. 5 decanone. 5 emphasizing where the ketone is at. You may also see this called deca 5 on the end. I have no preference. Okay, let's work on the next one. Now, I'll name it for you guys, but I want to make clear that this compound here, you guys will not have to name. This is an amide. It's a different type of functional group. I know it's an amide because I have this combination going on. This nitrogen bonded directly to a carbon that's double bonded to an oxygen. So it's got that carbonyl oxygen, but the nitrogen is also bonded to a second carbon on the other side. That means it's an amide, okay? It's a different functional group we haven't learned, but we do, I will go through the naming of it with you. So we need to identify what's attached to the amide. The amides are named similar to esters, where we name the alkyl portion first, the alcohol portion first, and then the carboxylic acid portion second, where the alcohol portion is from that nitrogen. And so we're going to name this portion first, this 1, 2, 3, 4, 5, 6, okay? We're going to name this portion with the double bond second, 1, 2, 3, 4, and then we just have this methyl group off of it. And so there is some example like this in the notes from class where we saw this letter N coming into play instead of a 1 or a 2 or a 3. N, capital N, means it's directly bonded to the nitrogen. So we're going to have to emphasize that in this compound to name where these things are at. Again, you guys are not naming this, so don't worry too much about that, okay? But I have this methyl group here, so I have N-methyl. Now I'm going to name this portion of the molecule because I'm going to leave the carboxylic acid looking portion for last. When I number that, I've got 6. So I've got hexane there, which we'll call hexyl. I see that I've got a methyl group at the 4th carbon and a fluorine at the 2nd carbon. So I've got N-methyl. I'm going to go alphabetically here. So 2-fluoro. Let's just zoom this in. 4-methyl. N, because it's attached to nitrogen. Hexyl. Now we can finally name the last part of it. So I've got 4 carbon there, which is a bute. But I've got a methyl group at the 2nd carbon. And bute. And then instead of saying oic acid like an alcohol, instead of saying OH like an ester, we say amide. The amide or amide, depending on who teaches you how to say it. I've heard amide and amide. I recognize them both. So you're not going to be naming that one. Don't worry about that. But just to show you what that looks like. I need to shrink that so I actually have some space for some things you guys do have to do. Okay, the rest of these compounds, though, fair game. So let's go through them. First up, we have to recognize what type of functional group we have. We do see that we have a benzene ring, but notice we have this OH group on the benzene ring. That means that this is a phenol. The kitten is back. The sister of the kitten is back. The other kitten. So if you hear that, I apologize. They're like 9 months old. They do what they want. 1, 2, 3, 4, 5, 6. Why did I number it that way, not the other way? I numbered it because of priority. The NO2 group, it gets a higher priority than a methyl group here. Hydrogens take the least priority, then carbons, and then nitrogen, oxygen, etc. would take a higher priority. So I'm going to name it like this. I've got at the fourth carbon, I have a chloral group. The second, wrong button. Trying to scribble the C out. Chloro. At the second carbon, I have the amine. Or, sorry, not amino, nitro. That is an NO2. So NH2 is amino. And O2 is nitro. And at the 6th carbon, I have that methyl group. So alphabetically, chloro comes first. So I have 4-chloro. Doing great with my iPad today. 6-methyl. Dash 2-nitro. Phenol. Again, the nitro, or the chloro comes first because alphabetically. The methyl groups come second because alphabetically. The nitro group comes third because alphabet. And then phenol at the end. I just use the numbers to emphasize which carbons are actually attached to. Okay, I've got this compound here. I can see I've got 2 bromines attached to a benzene ring. They are in the 1 3rd position. Again, I'm going to number them to minimize the number on the bromines. So I don't want a number going this direction because it would not minimize those numbers on the bromines. I can either call this 1,3 dibromo benzene, or I could use the ortho meta para distinction. This is the meta position, so meta dibromine, or it's like dibromo benzene tells me the same thing as 1,3. Okay, the structure up here. I have this OH group attached to the benzene ring again. We just saw that a minute ago. That is a phenyl group. And then notice I have the CH3 group down here in the 4th position. So I can either call this 4-methyl phenol, or because it is in the 1,4 position, I know that is para, I can also say para-methyl phenol. You could also just call it p-methyl phenol. Some people abbreviate to the P. For this class, you either need to say you would either need to say 4-methyl, or you would need to say para, fully say para, not just the P. Let's scroll down to there it is. Okay, when I look at this one, I've got that nitrogen group in there. That means I've got an amine. I don't have anything double bond, so I don't have an amide, so this is fair game. You do have an amine. I've got 2 different things attached to it. Let's see. Which way do you want to go first? Let's go this way first. 1, 2, 3. I'm going to name the 2 side groups, and then I'll name the actual compound. Actually, you know what? No, this is not fair game. The way that I drew this is not fair game. You will not name this compound, so don't worry about that. I've changed it in my notes versus this one. So as drawn, you will not draw this. I'm going to white out. You're not going to draw this, or you're not going to name this, because the naming gets too complex for this course. This is what I've done to fix it. So please fix that in your notes. I apologize. We're going to name this instead. That double bond in there, we would have to prioritize the double bond. It would get the naming pretty complex beyond the scope of this class. 1, 2, 3, 4, or 3, 4. We see it makes no difference. It would give us the exact same name, so we're just going to number it like this. So looking at, this is a propyl group. And it has a methyl on the first carbon. This is a butyl group, and it has an ethyl at the second carbon. So 2-ethyl butyl, 1-methyl propyl, or sorry, no, I'm not going to call it 1-methyl. I'm going to call that that's the 2, 3, 4. I should really pay more attention. I apologize, you guys. This is sec-butyl. 2-ethyl butyl, sec-butyl, amine. I apologize. In my notes, I'd also cut out this compound, and so that's definitely why I wasn't reading it correctly. But that is a sec-butyl group. If I did cut out, if you're looking at the student notes, comparing, I have cut this out as well. And once I cut that out, it no longer becomes sec-butyl, it becomes the propyl. So if I cut that out as well, I have the 1, 2, and 3. And I would call it 2-ethyl propylamine. Okay, what about this one? The reason I make these structures and some of them become too complex is I just put, in the system we use to make them, I just put random structures together and put functional groups in random spots and then see what comes out. Sometimes that doesn't work very well, so I apologize. Here I see that I've got an aldehyde and I've also got an alcohol. So I got to figure out what takes priority. Aldehydes take priority over alcohols. So we will name this as an aldehyde, and this alcohol will be called a hydroxy group. So if I look at my longest parent chain, that's my longest chain. This one, carbonyl carbon has to be carbon 1 on an aldehyde. That is a just flat rule. We never emphasize where the carbonyl carbon is because it's attached to hydrogen. It has to be carbon 1. 2, 3, and 4. I've got a methyl group here at the 3rd carbon. I've got a chloral group here at the 4th carbon, and a hydroxy group also at the 3rd carbon. So alphabetically, 4 chloral, 3 hydroxy, 3 methyl. Let's see, 4 carbons in overall is bute, butan, and Al for that aldehyde. Let's see. This one also not matching our notes anymore because I made it too complex. I need to change this PowerPoint and I apologize. I'm going to match it to the notes so that you guys can see what matches the answer key though. So I'll get rid of this. Okay, and get rid of this one. I won't make you name things that complex. Okay, this is fair game. So first I gotta recognize what functional group I have here. I should be able to recognize this is that ester. And I forgot one more thing to cross off. Dang it. Okay, I've also crossed off this. I will try to remember to update this PowerPoint. Sorry, you guys. It might be updated on your end and just not updated on my end. I honestly don't remember when I last imported this into GoodNotes to do this. Okay, so on esters, you want to name the alcohol portion first and the carboxylic acid portion second. 1, 2, 3. 1, 2, 3, 4. Notice I have a methyl group here and a methyl group here. So I have 1, 2 dimethyl propyl. And then I have a bute. So butanoate. Instead of butanoic acid, I changed the oic acid to O8. So butanoate for the rest of the compound. Let's look at this one. Okay, this one I have also changed slightly. This one does not have the double bond here anymore. Let's see. Instead, I put the double bond here. Okay. If I look here, what is my functional group? First thing I should see is functional group. I've got an OH and I've got a double bond. The OH takes precedence over that double bond. So this is an alcohol. I need to find the longest parent chain that includes that OH group, but I want to minimize where it starts. So I'm going to start down here. And if I go like this, I can incorporate that alcohol, that OH group into my longest parent chain, and I can get the longest chain. 1, 2, 3, 4, 5, 6, 7, and 8. If I'd gone the other way, it'd been 5, 6, 7, and that would not be the longest chain. And so I don't want to do it that way. I want to do it this way so I get the longest chain incorporated. Okay? Now I got to emphasize where things are. So at the 6th position, I have an ethyl group. The 3rd position, I have methyl. 5th position, I have ethyl. 5th, I have my ene. And 3rd, I have my alcohol. Notice this alcohol is a secondary alcohol. We don't put that into the naming, but you should be able to recognize it. It's secondary because the carbon it is attached to 2 other carbons. So secondary alcohol. Now I need to put these things into alphabetical order. Let's see. Ethyls come first, so 5, 6. I have 2 of them. Diethyl. Methyl comes next. Where's my methyl? 3. 3 methyl. I have 8 carbons overall, so oct. I need to emphasize that I have that double bond. 5 ene. And then I need to tell you where the alcohol is. 3 all. So 5, 6 diethyl, 3 methyl, oct, 5 ene, 3 all. Okay, let's go down to the next one. This one actually is pretty simple. 1, 2, 3, 4, 5. Again, I'm going to name it. I'm going to number it backwards like that because I want my branched group to have the lowest possible number. If I numbered from the other side, it would be at a number 4. So I've got a methyl group here at the 2nd carbon. So 2 methyl. And then 5 carbons long is pentane. There's no functional groups here. It's just a straight alkane. This group here, it looks a little sideways, but you still need to be able to recognize it. This is a toluene. So I can either call this, so this would be in position 1, 2, 3, 4, 5, 6. I can either call this 4 bromotoluene, or I could say para bromotoluene. I don't need to emphasize where the methyl group is because by saying toluene, I know that I have a methyl group and that becomes the first carbon. What about this one? Okay, 1, 2, 3, 4, 5, 6, or 4, 5, 6, 7. We're going to go with the 5, 6, 7. This is going to be my branched group. So this is my branch. It doesn't matter if I start counting from the other direction. 1, 2, 3, 4. It's symmetric, so it's going to be at the same position. That branched group is called isopropyl. It's at the 4th carbon. So 4 isopropyl. There's no other functional group, so it's just an alkane. I have 7 carbons in the longest parent chain. So heptane. So again, 7 carbons in my longest chain, heptane. I have a benzene group with an iodine attached to it. So just iodo, benzene. Remember the halogens become O at the end, so fluoro, chloro, bromo, iodo. And then I just have it on a benzene ring. Let's see if I count this one. This one looks a little funky because I didn't give you skeletal structure. These ones are a little harder for me to see because they just look messy. But I'm going to start counting from this side because I want my constituent group here to have the lowest number. So 1, 2, 3, 4, 5, 6. I got a hexane. I don't have any double bonds. I don't have any other functional groups here, so it really is hexane. And so I have 3 methyl. Hexane. That methyl group, that CH3 group, is at the 3rd carbon. I know some people like highlighting their parent chains. If you need to do that, please do. It can definitely help. Okay, what about this one? I've got this double bond here. This is an, remember this is an alkyne. And I need to get that in the chain. So I need to number it to minimize that where that that triple bond shows up. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Which way do we want to number it? Let's see, if I number it this way, I've got an isopropyl group attached. If I number it this way, I have 2 branches. We want to maximize the number of branches if we can. So this way gives me more branches, and 5 and 6. And that gives me the same branches. So I'm just going to number it like this. Again, some people say, well, why don't you number it like this? If I number it like this whole thing becomes 1 branch. When naming, you want to maximize the number of branches you have because it makes the naming easier. If I go like this, I apologize, 1 second, 5, 6, then I have a branch group here. I have an ethyl group here and a methyl group here. That's giving me more branches than if I number it the other way. But the argument could be made, why don't I do this then? Because same thing, the methyl group would be a branch right here, the ethyl group right here. And so that's giving me the same numbering as if I just leave the 6 up here. And if I leave the 6 up here, it's slightly easier to see the methyl group down here and the ethyl group up here for students. So I've got an ethyl group and a methyl group. I know it has to go alphabetical. My ethyl group is at the 4th carbon, so 4 ethyl. My methyl group's at the 5th, 5 methyl. I have 6 carbons overall, hex. I need to emphasize what carbon that triple bond is at. It's at the 2nd carbon, so 2 and ine, emphasizing that I do in fact have that triple bond. This one here is just the ball and stick model. Hopefully you guys can just see 1, 2, 3, 4, 5. It is just pentane. Just looks a little different because we're not used to as used to looking at the ball and stick model as we are skeletal or condensed formulas. And this one over here, hopefully you can recognize the functional group here. This is a ketone. Again, ketones have that carbonyl carbon, but that carbon is attached to 2 other carbon atoms. So I look for my longest chain, and I see I've got bute, because I've got 4 carbons. I do need to tell people where that ketone is at, though. I'm going to minimize the number on it, so I'm going to draw it so it's got the lowest number. So 2 bute and one. Okay. Next one. Okay. Here we've got, recognize your functional group again. You've got an aldehyde. Which means this carbon has to be carbon 1. I have 5 carbons long, no branches, nothing, pretty simple. It's just pent and al. Al for aldehyde. Got a benzene ring again, and I've got 2 ethyl groups attached. So you guys should be able to recognize this at this point as an ethyl group. So I can call this 1,2 diethyl benzene. Or I could say ortho diethyl benzene. Hopefully you recognize here, this is a carboxylic acid. So we know that this has to be carbon 1. We have 6 carbons long, no chains or anything like that. 6 is hex, hexanoic acid. Let's see, this one we have an alcohol. So we got to find our longest chain. One, 2, 3, 4, 5. Looks like our longest. If I went starting here, it'd be the same. Let's see, if I started here, 1, 2, 3, 4, 5, it'd be the same. Leaving and it's still giving the OH group at the third carbon. So no matter what I do, I'm going to get it at the third carbon. I do have to name my methyl groups. So notice I've got 2 methyl groups here. So I've got 2,4-dimethyl. Pentane is 5 carbons. So I've got pentan, 3, all. Emphasizing that alcohol is at the third carbon. Down here, this is a carboxylic acid again. So recognizing your longest parent chain. Sorry, I'm fighting with a kitten. One, 2, 3, 4, 5, and 6. So I've got the hexane group again, or the 6th carbon. Hexane is that base. I've got 1 methyl group attached at the 3rd carbon. 3-methyl hexanoic acid. Okay, this one, let's see. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7. Nope. If I started here, it'd be the same. So this looks like it's my longest chain. Nice and easy down the center. I have a chloral group, a methyl group, a second methyl group, and an ethyl group. So chloral gets named first. My chloral is at the 4th carbon. 4 chloral. No, that is the 3rd carbon. I can read my own writing. That is in fact 3rd. My ethyl group is at the 4th. 4 ethyl. Then I have 2 methyl groups, one at the 2nd carbon and one at the 4th. So 2,4-methyl. And then just octane, because it's just a straight octane. Looking at this one, 1, 2, 3, 4, 5, 6, 7, and 8. If I counted the other direction, 1, 2, 3, 4, 5, 6, 7, and 8. I don't want to count that other direction because I want to minimize the number on that substituent group attached. So I want to minimize what this number gets. Remember, when you have a benzene ring attached, we call it a phenyl. It's at the 4th carbon, so 4-phenyl. Octane. Now this one's a little confusing. I've got that ester group, so I know I'm going to have to name the alcohol portion first and the carboxylic acid group second. The alcohol portion is just 2 carbons, 1 and 2. It's just an ethyl group, so I'm just going to call it ethyl. And then the carboxylic acid group has this carboxylic acid with its benzene ring. This is actually called benz O8. It's emphasizing that the benzene ring is the only thing attached to that carboxylic acid portion. Draw the fully condensed formula for each compound. This means your skeletal structure. So 1 pentene. Pent means 5 carbon. Ene means double bond. And 1 tells me where the double bond is going to go. So I've drawn my 5 carbons, and my first carbon gets that double bond. 4-methyl hexanoic acid, so this tells me carboxylic acid. So I know this much. Hexanoic tells me I have 6 carbons long. This is carbon 1, so I have 5 more, and then 4 methyl at the 4th carbon. 1, 2, 3, 4, 5, 6. Got to draw my carboxylic acid on there. So again, 1, 2, 3, 4, 5, 6. Okay. The fourth carbon, I have that methyl group. 1, 2, 3, and 4. 2,3-dichloryl 4-ethyl 2-hexene. Okay. Hexene tells me 6 carbon. Ene tells me double bond. 2 tells me where that double bond is. So let's do that first. 1, 2, 3, 4, 5, 6. And my double bond is at the second carbon. What that means is it starts the second carbon. Okay. So it goes second to third, but second carbon. Now, we can do the rest of the name. At the second and third carbons, I have a chlorine group. So at carbon 2, I have a chlorine. And at carbon 3, I have a chlorine. At the fourth carbon, I have an ethyl group. Three-ethyl 4,5-dimethyl pentane. Pentane tells me all single bonds. Pent tells me 5. So let's draw that first. There's my 5. Now we can just go down the line. 3-ethyl. At the third carbon, I have an ethyl group. At the fourth and fifth, that doesn't even make sense. I can't have a methyl group at the fifth carbon because that's the end of the chain. So let's just go ahead and say 2 and 4. Yeah, we'll just do that. We'll say 2 and 4 there because that doesn't make sense. 3-ethyl 2,3-dimethyl. That should just be a single line here, not a double line. 2-pentanol. Pentanol is telling me alcohol, which is the ROH group. Pent is telling me 5 carbons. Let's try that first. So I have 1, 2, 3, 4, 5. And then my OH group. Okay, so that's my pentanol. Pentanol. Pentanol would be aldehyde. Pentanol. At my third carbon, I have an ethyl group. At my second and third carbon, I also have a methyl group. Hold on a second. I did not read that well. The 2 is telling me where my alcohol is, and I should pay attention to that. It's not a terminal alcohol. Let me start that over. So the second is where my alcohol is. That makes more sense. That is a secondary alcohol. So it's the carbon that the alcohol is bonded to, the OH group is bonded to 2 other carbons. But that 2 is telling me where it is on the pentanol. We now often say pent and 2-ol, but I would accept either one. 3-ethyl and 2,3-dimethyl. 3-phenyl 1-propyne. So this is telling me carbon-carbon triple bond. Prop is telling me 3 carbon. So 3 carbon. First carbon has that double bond. The third carbon has that phenyl group. I definitely missed drawing an entire carbon. There we go. 1, 2, 3, and then the phenyl group. 3,366 tetraethyl. That means 4 ethyl groups. 4 octine. Octine is telling me triple bond, and the 4 is telling me where that triple bond is at. So we've got oct, meaning 8 carbons. So let's draw that out first. 2, 3, 4, 5, 6, 7, 8. The fourth carbon has a triple bond. 1, 2, 3, 4. The third carbon has 2 ethyl groups, and the sixth carbon has 2 ethyl groups. 6. 2-ethyl 1-pentanol. Alcohol, 5 carbon. This is telling me that that alcohol is terminal, meaning at the end of the chain. 3, 4, 5, OH. So this is carbon 1 over here, which means 2-ethyl here. That looks funny. Let's see. Draw 3 isomers for each of the following molecules. C3H8O. Anything you can draw that fits that formula. Let's see. 3 carbons. OH. That's one of them. That's one of them. Let's see. That would also do it. C3H5Cl3. Got 3. Let's see. Cl, Cl, Cl. 1, 2, 3. Cl, Cl, Cl. 2, 3, 4. 1, 2, 3. Yes. 1, 2, 3, 4, 5. That would do it. Cl, Cl, Cl. That would do it. That would do it. So again, if I go back through these, 1, 2, 3 carbons, 3, 6, 7, 8 hydrogens. 1, 2, 3 carbon. 3, 4, 5, 6, 7, 8 hydrogens. 1, 2, 3 carbon. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. 1, 2, 3 carbon. 1, 2, 3, 0, 4, 5 hydrogens. 1, 2, 3 carbon. 1, 2, 3, 4, 5 hydrogen. 1, 2, 3 carbon. 1, 2, 3, 4, 5 hydrogen. 1, 2, 3 carbon. 1, 2, 3, 4, 5 hydrogen. Let's see, C4. Let me shrink these. There's possibly more structures too. I truly don't know. I just kind of draw them until I get bored. I think that's exhaustive for those two. The bigger formulas you get, the more combinations you can have. C4H6O. 1, 2, 3, 4. See if I put a double bond there for the carbonyl. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to need a double bond somewhere else. Let's try this. 1, 2, 3, 4, 5, 6. That would do it. Double bonded oxygen up here. That would be it. This is trans. This is cis for those double bonds. C5H13N. Again, it's probably not an exhaustive list. You may be able to find other structures. But just being able to use a formula and draw different isomers is useful. Let's see. You find a bottle in a lab labeled dimethylpentane. This name is ambiguous, so draw all possible structures consistent with this name. Name each structure drawn. Okay, so we've got what did it say? Dimethylpentane. Well, I know that if it's pentane, that means 5 carbon. dimethyl. Where could I put the methyls? I could put them here. I could put them here. I could put them on the same carbon. Middle carbon. Let's name all of these. 1, 2, 3, 4, 5. This has 2,3 dimethyl pentane. 2, 3, 4, and 5. I have 2,4 dimethyl pentane. 1, 2, 3, 4, and 5. I have 2,2 dimethyl pentane. 1, 2, 3, 4, 5. I have 3,3 dimethyl pentane. So those are the 5 different ones I can think of. Actually, there's only 5. But they're all different, right? They all have different boiling points, different melting points, different similar properties, yes, but they will behave differently, be able to be separated. So how could I actually figure out if I got a bottle of it and I needed to know which one it was? I could just boil it if it's a liquid or melt if it's a solid, figure out what its actual properties are, figure out its density, figure out its refractive index or something like that to figure out one of its physical properties to separate them. Okay, let's see. Last slide. What is the relationship between each of the following pair of structures? Are they totally different molecules? Constitutional isomers, optical isomers, or cis-trans isomers? Again, cis-trans is where you have that double bond situation going on. So like we saw just a minute ago, a previous slide, cis versus trans. Optical is the chiral, which needs an sp3 hybridized carbon. And constitutional just means same formula but different connectivity. So let's look at the first two. C4H10 or this one. Well, the first thing to do is just figure out the formula. Here I've got 1, 2, 3, 4, 5 carbons, different compounds. If you add it up, this is actually C5H12. Okay, second one. 1, 2, 3, 4. Add up your hydrogens, it's 10. 1, 2, 3, 4. Add up your hydrogens, it is 10. They are the same formula, but they have a completely different connectivity. If I was to draw these out, this just, looks like this. Series driving me nuts. Where this is tetrahedral, this is tetrahedral, this is tetrahedral, and this is tetrahedral. It takes longer to draw out. They're all sp3 hybridized here. They are structural. Isomers. What about these two? Okay, I can see the one drawn out. What if I draw out the other one? Let's draw this one out. Looking at these, this carbon and this carbon are not chiral centers. Meaning these cannot be enantiomers. They are the same molecule. They can be rotated to be identical. Okay, this one. Remember, you have a carbon in the center here. Now, if I actually look at this one over here, I've got carbon with a CH3, an H, a Cl, and a Br. These are not connected the same. If I actually look at the formula here, this has 2 carbons. It has 4 hydrogens, a chlorine, and a bromine. This one has 2 carbons, 4 hydrogens, a chlorine, and a bromine. So they have the same chemical formula, but they are connected very differently. Notice this has a CH2Cl and 2 hydrogens attached. This compound is chiral center. But they are not enantiomers because they don't have the same connectivity. So they are structural. Isomers. Next one. I see my carbons. Let's figure out the actual formula here. I have 5 carbons here. I only have 3 over here. So C3H8 versus C5H12. They look similar, but when I add them up, different formulas. Completely different formulas. Okay, down here, I've got a carbon, 3 carbons. I've got 3 carbons again, but if I look, they're not connected the same at all. This one over here on the left has 2 bromines. This one has a bromine and then a bromine with a methyl group attached. They do not have the same connectivity. They do have the same formula though. They're both C3H6Br2, but they are structural. And the last one, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 7. Definitely forgot the one in the center. I was like, where? It looks different. 7. Different. Let's add this up. This is C6. Let's see, how many bromines do I have? 2 bromines and hydrogens, 12. Over here, C7. Still have 2 bromines, but I have 14 hydrogens. They are different. Different molecules entirely. Okay? Good luck.